Hello guys, let's start with another problem which is known as goat Latin. So what we are given? We are given a string sentence that consists of words separated by spaces. Each word consists of lower and upper cases only. Okay. So each word consists of lower and upper cases. Remember in the constant it is given a sentence has no leading or trailing spaces and all the words in the sentences are separated by a single space only. So if there are no leading or trailing spaces, that means we don't have to use trim functionality of a string because it is already given that there is no leading and trailing spaces. And each and every sentence is each and every word in a sentence is separated by a single space only. So there are no calamities going on within the sentence that there are multiple spaces in between two words. Okay, it is a normal in English sentence. Okay, for example, I speak good Latin. Okay, what is the question goat Latin telling us? That we would like to convert the sentence to a goat Latin. How to convert to a goat Latin? Here they are given some rules. First of all, if the word begins with vowels, okay, A, E, I, O, U, either in uppercase or lowercase, it totally depends. So we have to append MA to the end of the word. For example, if the word is apple, then it becomes apple ma. And if the word begins with a consonant instead of vowels, okay, remove the first letter and append it at the end and add ma. For example, if the word is goat, then it becomes ot g ma. Got it? And at the last, we also have to add one letter A at the end of each word per its word index into the sentence starting with 1. So, if we have sentence I speak good Latin, what it would convert if it is converted into good Latin sentence? I, it is starting from consonant I. So, I, ma, and 1A. Speaks, S is S is also like sorry, I is vowel, so that's why I, ma is added and 1A is added. Now increment the number of A. Okay, if we'll increment the number of A becomes 2. Then speak. First character in speak is S, which is consonant. So S, if it is consonant, then we are following second rule of the goat Latin, which says that if it is consonant, not vowel, then remove the first letter and append it to the end of the letter and then add MA. So it would become peak S MA with 2 A's. Now number of A's increases. It becomes 3 A's. So goat, here it is already given at OG ma with 3A because number of A increases to 3. Now A's increase, so it would be number of A's would be 4. Latin. L is consonant here, so it would be Latin L ma with at the last 4 A's. Got it? This is how we are making our sentences. What could be our logic, guys? What could be our logic? I want to tell you first of all, while solving these kind of classic string questions now, you just have to follow the rules of making another string. In this case, the goat Latin string that we are making from the string sentence. Okay, we have to make a goat Latin sentence. So we just have to follow these instructions. We just have to check for each and every word present in the sentence whether it is starting with vowel or a consonant, and depending on that we have to add MA, the conditions to it, and at last we have to add the index suffix, that is A's, the number of A's depending upon the word index starting from 1. Got it? So what would be our approach? Our approach would be very simple. First of all, we split our sentence string sentence into a string of array of words. Okay, and now we'll iterate through each and every word. Okay, we'll check whether the word is starting with vowel or consonant. So if the word is starting with vowel, what we'll do, we'll take a answer string or a answer string builder. Let's take a string builder, because if we'll take a string, while adding into the string again and again, we will be making new string object, because strings are immutable. Well, otherwise, in the case of string builder, we'll be adding into the same string builder. So let's take a string builder answer. So in the case of vowels, when the word is starting with vowels, we'll add or we'll append directly the word into our answer. Okay. If the word is starting with consonant, not with vowels, then we'll append our word from string. We'll append our word from the index 1 using the substring functionality. Okay, and at end we'll append our first character of the word into our answer string builder. Got it? At last, when both these two conditions are satisfied, within the for loop, we'll append goat suffix. Goat suffix is this, ma, ma suffix. That will append at the last, because it is common in both the cases, whether the word start with vowels or it start with consonant. It is common in both the cases that we have to append ma. And at after that, within the loop only, we also have to add one more loop, which adds the index suffix of a's depending upon the word index in the sentence starting with 1, because we have to increment this index suffix one by one as we move to another word of the string sentence. Okay. At last, we have to append a space, make the reconstruction of that sentence in our string builder, and as soon as the loop ends, we'll return our string builder in the form of a string using toString. Got it? Very basic. Okay, let's start our approach. So first of all, let's convert this string into array of words using a split functionality, and we are using our magical regular expression here to split the word into the string array of words, sentence into the array of words. Got it? Now take index suffix as 1. Here I am representing it with a variable a, because we are adding a as an index suffix. Okay, so at first it is starting with 1, so we have initialized our index suffix as 1. Okay, now let's take the length of the words array. Now let's iterate through the words array from 0 to n, and yeah, we have to store it into an answer. So we'll be taking string builder because it is mutable. Here, for every string s is equals to, for every words, we have to check whether the first character is consonant or vowel. So let's take out first character of word of string s dot caret 0, and check whether it is vowel. How? That if c is equals to a, C is equals to E, C is equals to I, C is equals to O, C is equals to U. Same with the uppercase letters as well. Let's copy them. A, E, I, O, and U. If the condition satisfied, then in the answer string builder, we'll append the string S. Else, answer dot append S dot substring from index 1 till end. Okay. Then in the answer string builder, we'll append goat suffix, that is ma. At last, we'll have to append index suffix as well as. So from 0 till A, we have to append A. Got it? At last, we have to increment our index suffix one by one. Okay? One more thing, we have to reconstruct our string. How we'll do that? We have to append a space in between two words. So if I is not equals to n minus 1, why I am saying if I is not equals to n minus 1? Because at the last word there is no need to append a space. Okay, so that's why from 0th word till n minus 1 word I am appending space. For n minus 1 word I am not appending any space to make a sentence. Hence dot append space. At last return answer dot to string. Easy. What we are doing, we are first splitting our string sentence into the array of words using the split function and a regular expression this is our magical line which converts the string sentence into the array of words. Now we are taking index suffix in the form of integer variable a is equals to 1. We are initializing it with 1 because it is starting with 1. Now we are taking out the length of the words and storing it into n, and we are using string builder answer to store our final string. We are looping around the array of words and we are checking whether for each word whether the first character is vowel or consonant. If it is vowel, then we are appending it directly into our answer string builder. And if it is consonant, then we are appending from the first index, and then we also have to append s dot substring 0,1, the first index as well. Here it is given. The goat becomes ODGMA. Ode in the is appending using the substring from 1 till the last index, and the first character G, which is at 0th index, is appending using this line, that is s dot substring 0,1. At last we are appending MA, that is goat suffix, It is common in both, in the consonant and vowel, both conditions. So I am appending it outside of if else condition. Like this goat suffix. In suffix is also common in both vowels and consonant conditions. So I am appending it at the last using a for loop and incrementing my index suffix. Okay. At last, I am reconstructing my sentence by adding I space in between two words. Here is the logic. And then I am returning my string builder answer in the form of a string. Let's try to run it. Oh, AEI. Here also it would be not there. I think it is fine now. Yeah, it is working absolutely fine for the first sentence, as well as the quick brown fox jumps over the lazy dog for the second index as well. It is working absolutely fine. Got it? Let's try to submit it. Yeah, it is submitting. So what could be a time and space complexity? So here are time and space complexity, both are big O of n square. Why n square? First, I'll talk about the time complexity. As I am n times because first n times because we are splitting the word, we are splitting our sentence into the array of words. So it takes n time. After that, we are using a for loop, and in the for loop, we are checking for vowels and consonant conditions. After that, we are appending the index suffix in a exponential form. As for first word, it is appending one time. For second word, it is appending two times. A is appending two times. For third word, it is appending three times. For fourth word, it is appending four times. For W minus N W words, it is appending W times. Got it? So that's why our time complexity is big O of N. In the same way, what about the space complexity? Space complexity is also, our time complexity is big O of N square. In the same case, our space complexity is also big O of N square. Why? In the first case, we are taking n spaces while building array of words. Okay, and while making the goat Latin sentence, we are again adding or appending index suffix one by one using a for loop, and in the same way for first word one time, for second word two times, for third word three times, for W words W times. Okay, like this we are doing here. Okay, so that's why our space complexity is also big O of n square. Hence our space and time complexity both are big O of n square. That's it, guys. Please watch, like and subscribe my videos, and if you are watching my full videos, try to solve quiz which at the last of the video, so that I can get rough idea how many guys are able to understand my videos, what improvements I need to do for these kinds of things. Please comment below. That's it. Bye bye.